Hello, welcome to CHEMBLAST program. So this is a video to show you how to solve the problem for the question in chapter 9, question 1. This is the question and we will look at it now. So we are asked to draw the structure of compound A, B, C and D. Okay, first of all, we need to look at what kind of compound we have here. So since you have a C double bond O group, so this is what we call carbonyl, and we can confirm that this is a ketone. Okay, so ketone is undergoing some reaction. So we look at A, what is the reagent we have here? So lithium aluminum hydride, this is what we call Li. This is the strong reducing agent. So what we will do in the reducing process, we will add in hydrogen. So we will put in the hydrogen, add the carbon and also the oxygen. Because of this, we will have an answer like this. So this is the H added from the reducing agent. Okay, so now we try to look at part B. So this is the reaction that involves the reagent of KCN and H+. In other words, we are having two species. One is H+, and another one is Cn negative, which comes from the splitting up of KCN. So when we have something like this, we call that a nucleophilic addition reaction. So it will add something across the C double bond O. So the double bond of C double bond O will disappear, and we will add in something across the oxygen and carbon. So since carbon is positive and oxygen is negative, we will expect the Cn negative, which is negative, will come and add to the carbon, and H+ will come and add to the oxygen here. Because of this, we would expect the product of B to be something like this. So this is the Cn added, and this is the hydrogen added. So this process is called nucleophilic addition. Now for part C, we look at the reagent that we have here. So this is something called derivatives of ammonia, saudara mara of ammonia. So you know ammonia? Ammonia is what we call NH3. NH3. Anything that has something similar with the structure of ammonia is called derivatives. So this is OH for this case. So what happens if when you have ammonia derivatives, they will react with ketone by the process called condensation. Condensation means removal of water. Water means H2O. So we will expect to remove two of this H away from the ammonia derivatives, and one of this oxygen will be removed, and they will connect together. So the nitrogen here will be connected to carbon with the bond of double bond. So the product that we will expect is something like this. Can you see now? So this is N that has the OH. After we remove the hydrogen, it is left with N with OH, and it is connected to the carbon here directly with a double bond. So this is called imine. Okay, now we are going to look at part D, and this is the reagent that we will look at. So this is a RMGX, something we call it as Grignard reagent. Grignard reagent is something very nucleophilic, because they will split between the R and Mg, which is carbon and magnesium. And magnesium, always remember, magnesium will be more positive and carbon will be more negative. So because of this, CH3 minus is the nucleophilic side, and the MgBr+ will be the more positive side, which is called electrophile. So you have a C double bond O here. So oxygen, always remember, it is more negative, carbon is more positive, and we will have an addition reaction. So double bond will disappear, and you have something added across carbon and oxygen. So negative love positive species, so they will be added to the carbon, and Mg MgBr will go with oxygen, so become, oh my god, OMgBr. But because you have another step which is called hydrolysis, so we will turn this into OH, because the H3O plus will provide the H plus and exchange with Mg2 plus. Because of this, the product of D is something like this. So this is the CH3 from Grignard here, and this H actually is from hydrolysis that will change the OMgBr into OH finally. So this is an alcohol. It's a very famous reaction to produce alcohol by using Grignard reagent and carbonyl compound. Okay, let's look at the question 1b. So the question asks you to suggest a suitable reagent. Reagent means something to react with pentanol. So pentane stands for 5 carbon. So let's try to draw pentanol. 1, 2, 3, 4. 1, 2, 3, 4, 5. And then you have Al. Al means aldehyde. Aldehyde is anything with C double bond O and hydrogen at the end. So this is aldehyde. So we have double bond O H. Okay. 1, 2, 3, 4, 5. 5 carbon. Okay, correct. So pentanol acid. So we also have 5 carbon, but this time acid. So means C double bond O OH. Okay. And for pentanol is 5 carbon as well. But we have OL. OL means an alcohol. Alcohol is anything with OH. So let's see what is the difference between aldehyde and carboxylic acid. So we observe that there is an addition of oxygen here, meaning that you have actually trying to add oxygen. So it means that we will need to suggest an oxidizing agent. An oxidizing agent means something that has a lot of oxygen. Later I will look at the answer. And for pentanol, basically you can see that we are actually adding hydrogen, because you can see that you have double bond has disappeared. There's no more double bond here. No more double bond. So you actually add in hydrogen here so that the double bond disappeared. And there is another hydrogen here, which is something like this. So for part B, we would like to suggest anything that has strong reducing agent. Reducing agent means something that has a lot of hydrogen. We'll look at the example. So the answer that we can suggest is for part 1, anything with oxygen. So KMnO4, you see, 4 oxygen. Sodium dichromate, 7 oxygen. So this is a strong oxidizing agent. Okay, so this is acidified condition and must have heat, so that it will be more aggressive. For part 2, we will suggest a strong reducing agent, something like Lia or Nabiha or Haha. All this will give you hydrogen. You can see from the formula they have plenty of hydrogen. So you just give any one of these. Okay, now we look at question 1c. So you are given 2 organic compounds, E and F. They have a molecular formula of C3H6O. So when something has double hydrogen from the number of carbon, 3 versus 6, which is 1 over 2. So we would expect this is aldehyde or ketone. Aldehyde or ketone. So from the formula, we can roughly guess they are actually from these 2 groups of compound. But they tell you compound E have given positive test towards Tollens reagent, but compound F does not. Meaning that this is Tollens. It is a test to differentiate between aldehyde and ketone. Okay, so Tollens actually will react only with aldehyde, but not with ketone. So this is the tips that we can have. So what we need to suggest? So we need to suggest an aldehyde that has a formula of C3H6O. H6O. So 3 carbon, and we have aldehyde here. So this is the only structure we can come up with. So 1, 2, 3 carbon, and make sure, because aldehyde, you must have a carbonyl group at the end of the structure, because there is no more carbon here. So remember, aldehyde has a hydrogen at the end of the structure. So E is an aldehyde, so this is the structure for E. How about F? F should be a ketone, because it does not give positive test towards Tollens reagent. So how to draw a ketone with 3 carbon? So we put a C double bond O, and we have another 2 carbon on the side. So that makes up the formula C3H6O. Okay, for the second part of the question, they ask you to write the equation for the reaction of compound E with Tollens reagent. So do you still remember Tollens reagent? Tollens reagent, actually we dissolve silver nitrate in ammonia in H3, and we also add sodium hydroxide. So how do we write the formula of Tollens reagent? So we show you something like this. So this is a complex form by dissolving silver nitrate in ammonia, excess ammonia solution. And this is the complex we will write. And because we have a lot of sodium hydroxide, we need to write the OH minus here. So this is a strong oxidizing agent, Tollens reagent. What they do, they will oxidize the aldehyde group. So we add oxygen here. Since ketone has no hydrogen, so they cannot be oxidized. So they will turn the aldehyde into carboxylic acid. But then remember, because we have a base here, base, when they meet with an acid, they will react. So what happens is the H here from the acid will be removed to combine with the OH minus to become water. And because of this, the structure of the carboxylic acid is now only left with the ion, C double bond O minus. If you put your NaOH completely with a complete formula, so you must write Na plus here. But since the question did not ask you to write anything complete, so we can just write OH minus. And the most important thing is what happened to the silver Ag plus after they undergo reduction. So they will be reduced into silver. So this is our silver mirror that we observe on the lining of the test tube, which is a very nice silver mirror seen at the test tube. So this is the end of the video for the question 1, chapter 9 of CHEMBLAST. Hope the video helps you in understanding and trying to attempt the question in a better way. Thank you.